Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we are going to be talking about questions related to circular track. So whenever you have people or any object running in a circle, right? So how do actually we solve the problems related to time, speed and distance in a circular track? So this is something which is important for the for various standardized tests such as GMAT, such as GRE, and such as CAT, right? So let's go ahead and get started, guys. Okay, so here we go. So first of all, we're going to talk about the directions because there are, just like on a straight line you have two directions, that is forward or backward. You have two directions in a circular track as well. So what are the two directions? The two directions are clockwise and anti-clockwise. What is a clockwise direction? A clockwise direction would be if you're running the same way the clock would run. So let's suppose this is the center of the clock and this is a clock. A clock will actually run in this direction, right? Because this is 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock. So the clock runs actually like this. And in anti-clockwise direction, a clock would run opposite of so a person, or the runner would actually run opposite of the clock. So that means the runner would actually be running this direction. So these are the two directions that you have in a circular track: a clockwise direction and an anti-clockwise direction. Right? Now let's say for example that our person, there are two runners and they're running in the same direction. So let's suppose there are two runners and they're running in the same direction. So let's suppose you have runner A and you have runner B, and they're both running in the same direction at their respective speeds. So let's suppose runner A is running at 5 meters per second and runner B is running at 3 meters per second. Right? And the circular track, we have the circular track, right? So runner A starts from here and runner B starts from here. They both start simultaneously, and runner A runs at 5 meters per second and runner B runs at 3 meters per second. Now let's say that the whole circle is of 15 meters. So let's suppose the whole circular track, so the distance of the circular track is 15 meters. So when I say 15 meters, I mean that this whole distance is 15 meters, right? So one complete circle would be 15 meters. Now let's suppose I want to find out that now eventually what will happen is that runner B would actually be somewhere here and runner A would actually be somewhere here. So what will happen is that runner A will be far ahead than runner B, and eventually what will happen is that runner A will make a complete round and will catch up with runner B. Right? When he makes a complete round, he'll actually gonna catch up with runner B. So we have to find out that after how much time will runner A catch up with runner B, right? Even though runner A has greater speed, but runner A is actually gonna complete one whole round and it's gonna come back and he's going to catch up runner B. Well, first of all, let's talk about the concept of relative speed. What are the relative speeds right now? Since they're going in the same direction, runner A is putting up 5 meters every second and runner B is putting up 3 meters every second. So runner A is actually putting up 2 meters every second. That is 5 minus 3. 2 meters every second. Runner A is finishing, let's say runner A is actually covering up 2 meters every second. And for runner A to cover up 15 meters between B and A, because runner A is going to do a complete lap and he's going to catch runner B. Right? So that means the time it takes for A to catch up B again would actually be distance is equal to speed into time, and our speed is 2 and our distance is 15. We have to calculate the time. That means runner A will catch up runner B in 7.5 seconds. Right? So this is what the case is. So let's suppose if I want to talk about this again, I'll just explain this again. So let's say runner A travels at the speed of 5 meters per second, runner B travels at the speed of 3 meters per second. Now what is the relative speed? The relative speed is 2 meters per second. Every second runner A is covering 2 meters, and for him to catch runner B again after completing one whole lap, I mean, you must be thinking that runner B is also running, so that would actually be more than 15 meters, but we're actually talking about relative speed here. A is putting up 2 meters every second with respect to B, and how much time will it take for A to put up 15 meters? That would be 7.5 seconds. And 15 meters means actually one complete round. So he will take 7.5 seconds. So if I were to generalize what I just did here, I hope you understood this. If I were to generalize what I did here, so let's suppose I want to talk about this. I want to say, let's suppose you have a runner A with a speed of A meters per second, runner B with the speed of B meters per second, and the total circular track. So total circular track is of L meters, right? So the total circular track is of L meters. Then the relative speed is actually going to be equal to A minus B meters per second. Then time taken, they meet each other at any point on the track. So the time taken for them to meet each other at any point of the track would be L divided by their relative speed. Right? So this is the time taken. It could be seconds, it could be minutes, depending upon the unit, sorry. So I hope you understood this point here, guys. I hope that is clear. Now, our next question would be, when will they meet exactly again at the starting point? I mean, when will they meet exactly again at the starting point? Now, this is a very easy question. Well, let's suppose that runner A is running at 5 meters per second and runner B is running at 3 meters per second. And the total track is of 15 meters. Now, if the total track is of 15 meters, A is going to be at the starting point after how many seconds? Well, he's going to cover a distance of 15 and he's going at a speed of 5 meters per second. That means he's going to be here every 3 seconds, isn't it? So runner A is actually going to cover the whole circle and he's going to be here every 3 seconds. So he'll be here 3 seconds later, 6 seconds later, 9 seconds later, 12 seconds later, and so on. And what about runner B? Runner B is actually going to cover it in 5 seconds because his speed is 3 and distance is 15. So 15 divided by 3 is actually equal to 5 seconds. So runner B is actually going to be here every 5 seconds, isn't it? He's going to be here 5 seconds, 10 seconds, 15 seconds, 20 seconds, and so on. So when are they going to meet at the starting point? That would be when this value equals this value. And when will this value be equal to this value? That would be when 3 and 5 have a common multiple, isn't it? So when will 3 and 5 will have a common multiple? Well, that would just simply be the LCM of 3 and 5, the least common multiple of 3 and 5. That would be 15, right? Another would be the next multiple of 15, that is 30. Another would be the next multiple of 15, that is 45. So this is the time after which, these are the seconds after which they will actually meet at the starting point. So I hope you're understanding what I'm trying to say here. Let me just go ahead and generalize this. So if I have, again, if I talk about the same stuff, that is A is traveling at A meters per second, B is traveling at B meters per second, and the whole lap is of L meters, then they're going to meet each other at the LCM of L over A and L over B. Fine. So they're going to meet each other. And again, I personally don't follow the formula approach. I'm giving it to you because that's another way to do it. But I personally always follow the logical approach, which I just did there in trying to show you with numbers. That is the approach that I like to follow. Anyhow, let's move forward. Let's talk about opposite directions. Now, this should be really easy now. So let's say we have again, we talk about the same example. A is 5 and B is 3, that these are their speeds. And we have the whole circle to be of 15 meters. But now they're running in opposite direction. So what is the relative speed now? What is the relative speed? If they're running in opposite direction, that means A is going this direction, B is going this direction. That means relatively they're putting 8 meters every second, isn't it? Because A is running at 5 meters here, A is covering up 5 meters every second, B is covering 3 meters every second. They are relatively covering up 8 meters every second. Which means to cover up 15 meters, they're going to take 15 over 8 seconds. So that means if I say that there is a person A running at A meters per second, there is a person B running at B meters per second, their relative speed is going to be equal to A plus B meters per second because they are running in opposite direction. And if the whole circle is of L meters, that means they will meet each other after these many seconds. Fine. So I hope this is fine, guys. I hope this is clear. So let's move forward. All right, let's see some questions here. Okay. So this question here says that when three persons A, B, and C are running around a circular track of L meters. Oh, okay. So this is the same stuff. I'm sorry about that. Let's move forward here. Okay, so this one says that three bodies A, B, and C start moving around a circular track of length 60 meters. So you have a circular track and the length is 60 meters. Okay, be careful with the units as well. From the same point simultaneously, so they're actually starting from the same point. With the speeds of 3, 5, and 9 meters per second respectively. When will they meet each other for the first time when they started moving? Now in here, this question is a little different. In this question, you have three bodies rather than having two bodies. So what will you do in this case? I mean, this is another case right here. So let me first go ahead and explain you. Okay, let me just go ahead and do this question that will actually explain you how to solve this. So let's say what do we do is first we find out after how many seconds will A and B meet, right? And then we find out after how many seconds will B and C meet. So let's try to find out after how many seconds will A and B meet. Well, A and B are going to meet after 60 divided by, what are the speeds? 3 and 5. And they're running in the same direction, isn't it? They're running in the same direction. So it's going to be 60 divided by 5 minus 3, which is 60 divided by 2, which is after every 30 seconds. This is for A and B. Let's talk about B and C. B and C will meet after how many seconds? So B and C would be 60 divided by 9 minus 5, which would be 60 divided by 4. That would be after every 15 seconds. So that means that A and B are meeting after every 30 seconds and B and C are meeting after every 15 seconds. So that means after the first 15 seconds have passed, B and C are going to meet. In the next 15 seconds, when 30 seconds have passed totally, A and B are going to meet and B and C are going to meet. That means they're all going to meet each other after 30 seconds, which means our answer is going to be 30 seconds. So I hope you're understanding my point here, guys. What I want to explain here is that first we find out after how much time will A and B meet, then we find out after how much time will B and C meet. And if A and B and C meet at the same time, that means A, B, and C are meeting at the same time. And so basically, if I want to just generalize this, sometimes generalization helps. So if I just want to generalize this, I would say that, let me just go ahead and delete that. So I would say that if you have three people, let's suppose you have person A with their respective speeds with A, B, and C, and the circular track has a length of L meters, right? So if they want to meet each other, when will they meet each other for the first time? They will meet each other. So A and B will meet each other after this much time. B and C will meet each other after this much time. So they are both going to meet each other. That would be the LCM of this and this. So this is how you find out after how much time will they meet each other. All three will meet each other, because this would be the time after which A and B will meet. This would be the time after which B and C will meet, and the LCM of this would be the time after which all of them will meet. Fine. So I hope this is fine, guys. Let's move on to the next one. Okay. So this question here says that in a circular track of 100 meters, A has a speed of 2. So A has a speed of 2. And B has a speed of 4, and it says that A starts after 10 seconds of the start of B. So that means B already is running for 10 seconds, right? So B is already running for 10 seconds. So B has already covered 40 meters, right? And now if you talk about the starting point, A is right here and B is right here, right? So distance between them is now 40 meters. Now the whole distance, so this distance is actually 60 meters because the circular track is of 100 meters. Now when will B catch A? Now this is a little tricky here because this is not the usual stuff that we're talking about, right? So when will B catch A now? Because B speed is more than A speed, right? So what will happen? Now when B will, let's talk about what will happen when B covers This is where I'll recommend you to go piece by piece rather than applying a formula here, because it is possible for B to cover the whole ground, like B to cover all of the ground and still not catch with A first time, right? So what do we have to do here is let's actually see what happens second after second. Now, what is the speed of B? Speed of B is 4. So let's talk about what happens after 10 seconds, 20 seconds, 30 seconds, 40 seconds, and 50 seconds, because you already know that these are the 5 answer options. So after 10 seconds, so how many seconds will they meet for the first time after the start of B, right? So he's talking about after the start of B. So after 10 seconds, B would have covered 40, A would have covered 0. In the next 10 seconds, B will cover another 40 and A will cover 20, right? Because A speed is 2. In the next 10 seconds, he will cover 120 and he will cover another 20, which is actually equal to 40. And as you can see that they're not at the same time, right? They're not together. So in the next 10 seconds, he will cover another 20 and he will cover another 20. That would be 60. So now you can clearly see that they would be together at the same time, because B would have covered 160 meters. So that means he would have covered the whole 100 meters and another 60 meters, and A would just have covered 60 meters. That means they would be together here after 40 seconds. Fine. So my answer is going to be 40 seconds. Let me just repeat that once again. Here the traditional formula won't work, because in this question B has already had a head start. So we talk about what happens after 10 seconds. After 10 seconds, B covers 40 meters, A covers nothing. Then in the next 10 seconds, B covers another 40 meters, A covers another 20 meters, right? In this next seconds, B covers another 40 meters, A covers another 10 meters, and eventually B catches up with A after 40 seconds. So I hope you're getting my point here, guys. I hope this question showed something to you, that this can get tricky, and the traditional formulas sometimes won't work, or sometimes you just have to do the questions piece by piece. So I hope this is fine, guys. All right. So thank you very much for watching this video, guys. I hope you understood this, right? And I hope the circular track questions were fine, and I hope that actually showed you how to solve these questions. Now we will actually be coming up with more videos in circular that would be for some various other exams, not for GMAT and GRE. For GMAT and GRE, guys, this is it. That covers everything. For CAT, guys, we'll be covering up with more videos, that is number of distinct points and they're going to meet at, all those things we're going to be covering up. So thank you very much for watching this video, guys. Make sure that you visit our website, you give us your valuable like on this Facebook page, and also you give your valuable feedback at this email address. So thank you very much for watching this. I'll see you in the next one.